typically the weather was more consistent and you knew what to expect. Now, out of the blue, same township, huge winds, ice storms, branches broken everywhere, windows broken, a lot of damages, and who pays for it?
You're listening to Build the Unbuildable, a podcast about designing dream cottages on some of the most challenging sites in Ontario's cottage country. All right, welcome back to another episode of Build the Unbuildable. I'm John Tyerman, and as always, I'm joined by James Pitropov, principal at Lakeside Architecture, Inc., and today we are talking about climate-resilient cottage design. I'm excited about this topic because we started to talk about it a little bit on our last episode, and it was a great teaser. It was a great segue into this one. So today we're going to talk about how cottagers can design retreats that are beautiful, comfortable, and prepared for a changing climate.
John, let's do the deep dive on this one. This is going to be interesting.
Let's do it. So let's start with this. James, what is passive design, and why does that matter for cottage owners?
Times have changed with design. Due to changing climate, more extreme weather, new possibilities for materials, new sensitivity to contaminants, mold, and so forth in the environment, in our interior environments, we need to reevaluate the way that we build and the way that we inhabit our structures. We have new options, and it's on a spectrum of even small interventions or decisions can be significant, right to complete environmentally integrated design. I like to think that a good degree of competent environmental design would be designing a structure that is resilient but manageable to build for most cottage owners.
How do you take advantage of things like the sun orientation or natural airflow or other different environmental factors that are unique to that one location? How do you factor all that into the design process?
In terms of designing in a way that is attainable for most people, that makes sense, it is a matter of responding to the environment and not always using heavy technology, but just using the knowledge and the wisdom that we've always had about building on site and being aware of the options that we have. So when we talk about passive, say, versus active, passive design can be as simple as stating your function, how many rooms you want, how you want your building to be oriented. Do you want sunlight in the bedrooms in the morning to start the day, or do you not want that? Do you want to have views of the lake? Do you want to use your building to create a microclimate on the site so it's not too windy or too hot? So by passive, I would say the first steps are to take the basic structure and to realize that we can use the layout to make the most use of not only views and a good flow to your building, but also to orient to available sunlight, block out wind, and this reduces energy consumption, and it creates a structure, a cottage, a house, a luxury home that works with the environment instead of working with outside considerations. This will become important when we realize the energy savings that we can have with, say, passive solar design versus heavy technology heating systems and so on.
Okay. And so I imagine that designing natural airflow, natural solar orientation into your design, the impact on the environment within the home relative to the environment outside of the home. So that's where that focus is, on that high performance envelope and what goes into that.
Yeah, and it's tricky because it's a balance of both. So there's two trains of thought, John. One is you have the type of environment that a lot of us might like, big windows in the right places, smaller windows on northern exposures and so forth, natural ventilation. Natural ventilation is great. On the other hand, mechanical engineers typically now do not want natural ventilation because it's harder to control the internal environment. They want a sealed system, heavily insulated, super high performing windows, don't even open them. And in order to counter that in Ontario, in our building code now, we have some rules about installing heat recovery ventilators so that when we're introducing fresh ventilation into buildings and when it's circulating, the heat is being extracted on the way out and heating air coming back into the house. Sounds technical. I promise this will get more interesting. Basically, we're controlling the environment, but we need to know what we truly want for a cottage interior comfort.
We're setting the stage right now because this episode is focused on climate resilient cottage design, and the underlying premise there is that the climate is shifting and there are changes happening every single year that are different. And we're experiencing more extreme weather, for example. And so building for durability, when we think about this and we know that there is a changing variable with the external environment, where do you typically point to places in the building code, for example, and you say, well, let's go beyond that in this area or beyond that in this area? What are some of those different examples of like areas where you advise your clients on a build to go over the top?
Well, here's where things get interesting, and they've changed quite a bit from the past. Because of changes in the climate, the demands on the performance of the buildings is increasing. And some of the things that are happening, which we can see out there, are there are more extreme weather events. And this is really undeniable. And just two examples here. In the township we're building in Cottage country here in southern Ontario, currently there is a all-out fire ban. And it's been incredibly dry. If you've been in the North Kawarthas, you can look it up online. We're typically in a warm summer, but overall cool winter climate type of environment. It's been incredibly dry and hot, burnt out grass everywhere. Trees look like they've dropped their leaves. It's incredible to see what's happened over the last few months. Previously, we didn't get this kind of extreme weather condition. Now what's happening is there are fire bans with huge fines attached to them, which are, I think they're necessitated because of the high risk. Very easily, one can imagine somebody throwing a cigarette out or playing with fireworks at the cottage and starting a forest fire. The forest fires have started. They were very hard to put out. It's a real risk. The risk now to owners is if we're building the same way we did previously and your place burns down, insurance companies are not paying for fire damages or other, quote, acts of God, because that's what they view them, just sort of uninsurable weather events.
But isn't that what you get insurance for in the first place?
There's now with more frequent weather events, John, I think you'd be hard put to find somebody to replace your $1 million bill. It just doesn't seem like it's going to happen.
Wow.
The second big risk, John, that we saw in the winter, ice storms. So typically the weather was more consistent and you knew what to expect. Now out of the blue, same township, huge winds, ice storms, branches broken everywhere, windows broken, a lot of damages. And who pays for it? You can check your insurance. They are not going to insure those branches coming through your windows in most cases. So we need a plan B. Thirdly, just overall in terms of having a design that is going to withstand the elements, the more extreme elements, conditions that may come once or twice a year but are more far-reaching and devastating, we need to build in a smarter way so that your cottage, your structure, your investment is more resilient to these events that are popping up.
Well, that's exactly right. So it's if insurance isn't going to cover it, then you need to invest in a different kind of insurance. And that other kind of insurance is the design of your build and the materials you use in your home and how much like you clear away from your house to the edge of the woods, for example, is a type of insurance against wildfires.
Yeah, just a practical measure, clearing out around your structure, the materials that are used, various systems and backup systems. Another risk that we didn't mention is now with more extreme early spring weather. up in cottage country here, things will be frozen, and then all of a sudden, early spring rainstorms, when typically there will still be snow, the ground is still frozen. It's raining. The water levels go up. A lot of the lakes, they're actually on river systems, and they are controlled by dams. But regardless, some of the big lakes a couple of years back were completely flooded. Look at Lake Muskoka. These are water controlled lakes somewhere in the system. They are water controlled, but in the spring, the water came up. Boathouses, millions and millions of dollars of boathouse damages. Water came up, ice came, sheared boathouses off their piers. It's getting crazy, and you need to have your plan B, which really should be your plan A. It's designing in a smarter way so that your construction is more sturdy and it is more resilient to fire, to rain, better insulated, better heating, and ventilation systems is where it's heading.
So let's unpack that a little bit. So we talked about wildfires. We talked about flooding, especially recently on Lake Muskoka. Let's start with wildfires. We talked about clearing around your cottages. What are some other practical steps that cottage owners can take to defend their structure from wildfires?
Well, that's a great question, and that's where the answer to this is the direction where things are heading. Now, John, in the most recent building code, there are measures towards incorporating better fire systems in residences. There's a move towards putting sprinklers in residences. Like we have it, like we have the opportunity to do that now. Why not build? Why are we building in cheap softwood, for example? Should we be building in steel? Should we be coating that steel with intumescent coating so that if a fire starts, the coatings they expand and they protect the steel from collapse and so on. If you watch some of the videos out there, you will see how quickly structures set ablaze. And in a lot of cases, like we're building with big timbers, but these places have fireplaces and so on. And the idea with big mass timbers is that when they burn, they char, but they don't burn straight through.
Right.
But we have to be mindful of the materials that we're using. The typical cottage with board siding, and in a lot of cases, the builder special cottages where they're using painted foam moldings. Yes, this is what they're doing. It's all under there. Painted foam or soft pine. That will go up very quickly in a fire. Why are we building like that? In other places, people build in concrete, they build in steel, and we're still building with very unresilient materials that are not going to last very long under fire conditions. To the point where it almost makes it impossible in a fire for people to get out of a residence, which is just a fact.
Yeah. And if insurance isn't going to cover these acts of God, then that needs to be factored into, how else are you going to defend against it?
Well, if you look at hurricane damages down in Florida, they're not covered, or various states have their own perils.
Yeah.
Some of the perils up here also include flooding. So everyone builds their cottage on the water. That bedrock is typically about 3 feet down on most of the Muskoka lakes, covered by sand and silt and sometimes. So what happens when the water comes up, or are your footings sitting in the water? And in a lot of cases, low-lying cottages, particularly a hint would be if you're next to a environmentally sensitive area, an EP area, usually it's a wetland area, and you are sitting on low-lying land, and which may or may not be permitted, but in a lot of cases it's grandfathered in. So what happens from your foundations getting wet? Some of your assembly water's gotten in. There's various types of mold. I mean, it just happens. Everybody says, well, there's mold everywhere in cottage country. Well, but we have new tools that we can use now, and things. We have more modeling and more focus on various assemblies, and we can learn from what we've seen in the past. But there's more flooding now. It happens every year here, it seems now, in different areas too. So if your structure's getting wet, your 2x6 wall, which is wrapped conveniently with poly membrane, like a plastic membrane, when that water comes out, gets in, it just doesn't come out.
Right.
Everything needs to be cut out. It needs to drain. And this happens so much more than you think. Why are we still building in that particular way? Maybe we need to evaluate how and where we are building.
So let's walk down that path a little bit. So can you walk through, maybe it's different elevation strategies or drainage approaches to drainage or different materials choices, especially in areas that are prone to flooding or have flooded recently, maybe in recent years? What are some of the different tips and tricks that how you approach that?
Well, here's the mini boot camp on how to stay out of trouble with the elements up north. And the advantage that I have, John, is just purely being on different properties and lake systems and river systems, and really it's mostly practical. People feel free to agree or disagree or add in, but they're mostly common sense, but leading towards better design. So the first thing, just in practical terms, is we're building on lake shore, Lakeside, hence the name, Lakeside Architecture Inc. We're building on the waterfront. Well, we can take a couple of conditions. Building on the waterfront and building on low-lying shorelines. Do we still, in this day and age, do we really need full-size basements? Oh, let's have a basement, a lockout, a basement with a lockout. Well, you're digging down still and you're pouring your foundation. If you're on a slope like you are on most lake sites that we're working on, there's water coming down the hill at the bedrock. It's meeting your wall. So your wall has to act like a retaining wall. Hardly anyone considers that, and they don't engineer it, but it is a retaining wall because it's holding water back.
Yeah.
So what we do is we'll have weeping tile underneath the slab at 3 points along the wall, and possibly some pumps as a backup. I don't like to have a backup when something can be designed differently, but this is the way people build on the slope. So my question is, building on a slope like that, we're removing all the topsoil and all the sand and soil and whatnot. We're all in the rock. You can barge the bedrock and cover it. There's different ways of doing it. It still wants to sweat. In a lot of cases, what we've done is we'll put hydraulic cement on it. It covers things up. But why do we need a basement on a cottage? We'll think a little bit more modernly, in more modern fashion, just for a moment. And can we put things on piers? In some ways, it makes a lot of sense. It's faster, easier to build. You're not holding back the water. The argument might be, well, we have the well pipe coming underground, and we have some services, so forth and so on. What I'd like to suggest is you can still have a partial service basement if you feel you need to have it. I wouldn't mind if you put your services in a separate building where it's accessible, where it's going to be above the ground, or if you have wells and so on, the well can come directly into the space. But the first thing is, let's consider getting you off the ground. Mm-hmm. So just a very basic thing. The second point is, in terms of materials, are we still building 2x6s and 2x4s? Heaven forbid, we don't use stucco or any of those materials. A lot of builders still do. The issue with stucco is that approach is keep the water out, seal everything like super tight, so you can have your California style stucco build. The thing is, that works in California and dry climates. Over here, water will get in, and when it gets in, it can't get out. And you can try to drain your walls, and you can do all sorts of wonderful interventions, but it makes sense to have buildings that can breathe and drain. So some options are we will build a typical shell, and then can we build a rain screen around for your building envelope around your cottage? Meaning we're going to strap it out. We know water's going to want to get in, and it can get in, and it will run down the impervious membrane behind your cladding, and it allows it to drain, and it allows the planks to dry as well. There's a whole set of beautiful cladding approaches and details that you can look up online. Modern rain screen cladding, good way to go. We're still working with wood. Wood can get wet, but it can't stay wet. So that is a thing, and it doesn't want to be trapped in concealed spaces. The third approach is, should we be still relying on 2x6 construction, 2x4 construction? And the reason I put that out there is that inherently there are problems with it in cottage country. Everybody does it. It's going to be on a lot of structures. The thing is, water gets in, and with those high humidity environments, 80% humidity, 85% humidity, 95% humidity, check it out at your cottage. In the summertime, it's going to be like 95% humidity. Really humid. Carpet ants get in there too. Things get moldy. Why are we still building that way? I'm tending towards building in larger timbers. It just reduces that amount of small structure. Performs better in a fire. I can put panels on it, and then I can use cementitious panels, so fiberboard or cement or even steel assemblies. I'm not saying that you have to do that exclusively. I'm saying that could be part of the discussion for your particular project. Let's build resilient, because cottage country is a harsher environment. It's not the city. 4 seasons, 4 very fulsome seasons. And what I'm discovering over the years is just a whole different challenge keeping that environment optimal.
If I heard you right, basements are a big factor in that. Why need a basement in a
Yeah,
cottage?
do you need it? Like, I wouldn't tell anyone do it or don't do it, but my question is, let's put on piers. It's easier.
Yeah.
You're not disrupting the site, and you're not blasting. And let's be efficient. Save some money at it, and don't build a damp cavity in the ground.
That's right. Yep. And then put it on piers was the other thing that I heard. The materials that you're using, thicker timbers instead of the smaller pine material that's softer, absorbs more water, is easier for insects to get in. I'm curious though, we've talked about it on this podcast. Many of your builds are retrofits or renovations. So I'm curious, like, have you had to retrofit or renovate older cottages and updated them with some of these, more modern materials that are more resistant to climate changes and extreme weather?
Well, I'll give you an example, John. Just working on some century-old structures. They've been renovated so many times, and there's just layers and layers of materials in the walls and the floors. And typically they weren't insulated originally, but they were insulated at various times. But the vapor barriers weren't built in. The vapor barrier needs to be consistent, continuous. It has to wrap around floors, the warm side of the insulation. There's a whole series of requirements that is just not in the older structures. So when you cut into the old structures, how far do you go before it becomes a whole rebuild? And in a lot of cases, there's a lot of cutting and doing. So fortunately, on the cottage sites, if you are keeping an existing structure, in a lot of cases, it makes sense to build. If you're going to build new, I like to separate things with a breezeway or a Muskoka room, or you can call it a Kawarthas room if you like to do it. I like things to be separated with their own system, and that way you can stay high and dry, and your new structure isn't going to be hijacked by the shortcomings of your old structure, having discontinuous vapor barriers, carpenter ants, leaking roofs, flashing that's come apart at the fireplace. And I'm not saying that those things should stay in place, but when we're building, we need to make sure our new building is at the right standards. Is to code as a minimum. The building code is a minimum standard, and that it performs correctly. It's really hard to undo an old structure's shortcomings. It gets complicated.
Yeah.
Just open up the walls in your cottage, John, and you'll find a whole new world of curious, problematic construction.
Oh, I worked in construction in my early 20s, and busting apart old plaster walls, and then everything that comes out from there it can get a little nasty. So yeah,
It gets messy.
it does. So I'm curious, in cottage country, how often are there power outages?
Power outages are quite common.
Really?
Like very
Okay.
very common. Like and sometimes it seems like every couple of weeks, or particularly in the winter. And what can happen, John, is during inclement weather, the ice gets on those branches and they get super heavy, and then the wind starts up, and the hydro is down. That's a problem if you're running any sort of heating system and ventilation systems. Here in Ontario, part of the requirement now is having a heat recovery ventilator so that your interiors are prescribed amount of air circulation and so forth. However, the heating system and the air circulation, it stops when the hydro stops. So it's important to have a generator, like a backup generator, and perhaps equally importantly is to have neighbors. If you're not at the cottage regularly, have neighbors that are in the know, can tell you when power's down, can help out. There are handy people close by that'll get your generator started up again. Of course, now everything's automated as well, so you can know, we can set you up on the software, and you can check your place and see what's happening. All of a sudden, is it really cold? Well, maybe the power went out if it's winter, or somebody broke in, windows are open.
Yeah.
So everything can be done remotely, but there's a common sense, practical, everyday level of checking on things and having someone there that can check up on a backup generator. Might not sound super exciting, but that's how 90% of power issues are taken care of, particularly in the winter in cottage country.
I ask because of all of these changing factors in the external environment, more wildfires, more storms, rising tides on the river systems and the lakes, that can lead to more power outages.
The storms that are coming up are, like, the winter winds are just crazy. So I've done projects and am involved in projects on Georgian Bay, the east shore of Lake Simcoe, picks up a lot of wind, Bay of Quinte currently. And the wind that comes across is just going to blow that pretty standing seam metal roof. It is coming off. It's coming off in the winter. I can almost guarantee it. I'll give you an example on our Bay of Quinte project. The standing seam metal roof is being brake framed on site for the custom clip and then tightened with a special tool, super tight, so these roofs are not going to lift. As soon as a little bit of wind gets underneath, it wants to lift like half the roof. So it's a matter of knowing some of those details. Also in terms of windows. Those big, beautiful, oversized windows that you're going to put on your island and Georgian Bay, well, when that wind comes up, it's bad enough as it is. But now with the more extreme events, these very unreasonable gale come in, and what they tend to do is they push on the glass on big window areas and they make it deflect. And once it deflects and the glass touches the other pane, that glass wants to shatter. Mm-hmm. That's the reason on the big window units, typically they require it to be tempered glass or laminated glass. But 9 times out of 10, when I check out somebody's place and I look for the little CSA marking on there for tempered glass, I'm not finding it. So people are not building in a way that's aware of these environmental challenges. Now, to complicate things, when you have your big opening, the wall on top, there's some deflection over a long span. So the wall is pushing down above, and it's not only that it's pushing down on your window, like if you have a big snow load. So the wind is bringing in a lot of snow, it's pushing down, but if there's a little bit of wall underneath or above your window, let's say underneath, the wind is blowing on it, and it's a 2x6 underneath supporting a whole stretch of the window. It's not going to blow out or anything, but it's going to twist and rack, which wrecks your windows, and then your seals go, and people wonder, well, how come there's condensations in the windows now, or how come there's a hairline crack? So one detail that we'll use is we'll use a thermally broken steel plate, and that can be half an inch, even to 3/4 inches underneath on the big windows for this lateral movement. Now, this isn't the deflection that the engineers will caution you about. This is from the field. Like, this is from knowing in the winter that there's also additional force that people don't expect, where the wind is blowing, wanting to bend the window frame this way.
I didn't even think about the wind, especially, and then the way that if you have those big bay windows and how the way that the wind makes it want to bend. So tempered glass, reinforced underneath with a steel beam instead of those 2x6s.
With a steel plate on the flat,
There
so
you
that
go.
additional little force. Like this is what happens in the field.
But these are all things that, like you mentioned earlier, an engineer might not mention, but you have the experience from building in these environments and being exposed to the elements the way that you have. You have this, you're able to help communicate that with your clients who want to build a lake
Well,
house.
now and now that you know, you can go. Of course, you can go to your engineering and you can calculate. Get them to do the calculations and seal off on these additional forces. From my experience, it's just not obvious, and you learn it from being in the field. It's just there are additional growing challenges.
And while replacing cedar siding can be a pain in the butt, it's definitely not as bad as replacing one of those bay windows. Let me tell you that.
Well, John, when owners are building, one of the first things they ask about is longevity of materials.
Yeah.
They want low maintenance. They want things to last. Of course, there are all sorts of materials out there. Well, let's use steel panels. Well, let's use panels with a particular finish on them. This is what so and so has used. This has been used on a prominent building. Have a look around. Drive through the city, look at condos, bank buildings. A lot of them are detailed really well and they're lasting. There are a lot of condo buildings in the city, for example, and you can see the panels that they have. The steel panels, the kind of coating that they have on them is already faded, and you don't get your money back. It seems like there are warranties out there, but realistically, if you have to deal with warranties and insurance companies, you may be on the hook at a certain point. You might find you're told, well, it was the installation, it was the delivery, it was this, it was that. At the end of the day, if you put it on a new material, it has to have a bit of a track record. 5 or 6 years of projects in the field is not a bad start,
Yeah.
regardless of the claims of new materials. And materials that don't have certifications on Ontario, they're very suspect. They have to have their approvals here. They have to have their building materials evaluations, BMAX, and so forth in Ontario. They have to be legit. Here's a challenge. When you're out there and all of a sudden you're getting windows, they're discounted incredibly, and they're coming in from various locations around the globe. Well, they don't have the certifications. It's on the gloss. Well, now people on the black market buy them, put on the certifications.
Oh,
Nobody
no.
checks. And how will this perform? The answer is in small areas, probably, possibly okay. In larger areas, they do not perform. And this is why additional measures need to be taken. The reason I'm saying this is that cheap vinyl windows are not necessarily going to be your friend. You need performance. And performance may cost more money, but the big deals that are out there, they may not perform very well in an environment.
Very good. Well, for folks that are listening to this episode, for folks that are watching on YouTube, and resiliency in your cottage design is important to you, make sure that you factor that into when you're communicating your dream design to your architect. And James, you have a Design Your Dream Home guide available on lakesidearchitecture.ca. If folks that are listening to this or watching this and they do want to incorporate more resiliency into their design, how is the best way for them to communicate that using this guide?
Well, John, here's what might work for your viewers. You can get on to lakesidearchitecture.ca, and the guide is there. The guide was developed to help you as the owner organize your own ideas. It's not going to give you ideas, but it will help you organize your own ideas. Then I would recommend, while you're going through that process, get on our social media. You'll see projects that are going up currently. And the way I've dealt, John, ultimately with this whole resilient design is you'll see it in the projects. So I like to build on piers. I'll use concrete when I can. I use big timbers. They're actually performing really well. They're fire resistant. They are sturdy and they are beautiful. Instead of wood siding, I've turned to really interesting materials such as Corten weathering steel channels. You can see it on the project builds there. Really beautiful material. It will rust to a certain degree, and then it has this weathered patina look on it. The thing that clients love about the material is that it has the feeling of character, and over time, it will look better and better. If you find that it's weathering too much, there are retardants that you can put on it. If it's not weathering fast enough, there are accelerators, but you can control the appearance of it. And once that stabilizes, it stabilizes. It's not going to look worse in 10 years. It takes a beating from the elements. It's modern and cool, and it works really well in cottage country. Do a lot of concrete. I'll get concrete from a local quarry. We crush it, put it into concrete mix with Portland cement. You get a beautiful floors that we can embed hydronic infrared heating into, warm on the feet, beautiful to the eye, resilient structures, concrete, timbers, glass, steel. It's time to move on to sturdier structures. Compare it with your own notes with the guide. You can look up some of these materials independently online, but it will be exciting, and it will give you, it'll help you with your next steps toward developing your own materials that are beautiful to you, but will be resilient and maybe even look better over the course of time.
Excellent. Get inspired and follow Lakeside Architecture on Instagram, on LinkedIn, on all the other social media channels. Subscribe to the show on YouTube. Subscribe to the show wherever you get your podcasts. And James, thank you so much for this conversation. I learned a ton about how cottagers can defend against floods and wildfires and gale-force winds. This has been a fantastic episode and a fantastic series. Thank you.
Thanks, John, and to all the viewers, have fun and check it out, lakesidearchitecture.ca. Thank you.